Okay, so this is the video solution for question number 8. We are doing a binomial times a binomial, so this is going to be a 4-box area model. However, there are multi-variables in this problem, so it's definitely like a 10 to precision sort of thing. We want to be very careful when working through this area model. So we're going to start by putting one of our binomials along the top of our area model, separating the terms, and one along the side. Again, it can be the left side or the right side. We're going to draw a boundary between the terms on the top, draw a boundary between the terms on the side. That creates our 4 boxes if we finish it off, and we have 4 spots for our multiplication, our distributive property. So we're going to first start at the top left box, and we're going to go slowly through the product rule again, which states multiply the coefficients. So 3 times 3, no, is not 6, it is 9. Please try not to add. So we have 9. Then we're going to keep our common variable a, and we're going to add the powers. So we get 9a to the 4th if we do the top box correctly. The next box is the intersection of 3a squared and negative 2b squared going across the top. And so the 3 times the negative 2 is how I'm going to get negative 6. When we have an a squared, b squared situation, I tend to do alphabetical. So first I put the a squared, then I put the b squared. Unfortunately, since they are different variables, we cannot do anything other than just simply writing them as a product side by side. So we have all one term, negative 6a squared b squared. Bottom left box, remember, is going to be part of this diagonal, and what we've seen over and over again is that it's a like term with its diagonal counterpart. So keep in mind that if I wrote a squared b squared in the top right box, I'm going to try to mimic that in the bottom left box when I get to that decision. So first we're going to start with our coefficients, 3 times 2, and that's going to give us a positive 6. I have a squared b squared again, so because I did a squared b squared in my previous box, I'm going to do a squared b squared in this one as well. That way it's easier when it comes time to combine. Bottom right box is going to be a positive 2 times a negative 2. That's our negative 4. And we have b squared times b squared. Since they are the same variable, we keep the variable and we add the power. So it becomes b to the 4th. So far, this is what the area model looks like after doing the 4 multiplications, the distributive property doubling. So what we're going to do next is we're going to take a look at that diagonal of like terms, as I mentioned. And we're going to try to write our answer in standard polynomial form. So I'm going to start with my top left box, which is 9a to the 4th power. I'm going to record that here. And then I'm going to go to my diagonal and see what I can combine there. When I combine, I simply add the coefficients. So we have a positive 6 and we have a negative 6. Oh, we've seen the situation before. When we have the same coefficient opposite signs, we're actually going to lose those 2 terms. They what we call cancel. And we are left with 0 a squared b squared. So we don't bother to write that down. What we're going to move on to next is the bottom right box, which is negative 4b to the 4th. I know that I'm in standard polynomial form because my degree of each term is 4, and since they're even, it's really 9a to the 4th minus 4b to the 4th, or negative 4b to the 4th plus 9a to the 4th. Again, I prefer alphabetical, so I'm going to leave it this way, 9a to the 4th minus 4b to the 4th. And that's the final answer.